Hello, welcome back to Larry's Classroom. Today we're going to continue with our discussion of analyzing series and parallel circuits, and we're going to work with another example. I'm going to draw a circuit on the board and we're going to go through analyzing that circuit. Got a voltage applied, we got two resistors in series here. This is R1, which is 10 ohms, and R2, which is 20 ohms, and we got another branch out here, R3, which is given to us as it's also 10 ohms. And R4, which is unknown value. R4, we do not know R4. We are giving a IT of 6 amps. Of course, this flows out of the power supply from the negative to positive. We're doing electron flow. And we'll call this branch 1 and this branch 2. And we have a current of I1 in branch 1, which is 4 amps. So, let's begin by working on figuring out what the voltage applied is. Well, we know we're going to use this formula that we've used many times. Voltage equals I times R. Let's put capital A there for the amps, 4 amps here. Since voltage equals I times R, and we can see that the total resistance in branch 1 is R1 plus R2 is 10 plus 20, which is 30 ohms, so we're going to say branch 1. We have 30 ohms there. But we're also given the current through branch 1. And so we also have 30 ohms and we have 4 amps. We got 30 ohms by adding these two resistors together. We got the 4 amps was given to us. Now using this current times resistance gives us voltage. We're going to go V equals IR, and our I is 4 amps. We're going to multiply that, use the dot here, times our total resistance, which was 30 ohms. And that gave us 20 volts, or 120 volts. So we knew that VA, if we calculated VA, we knew the voltage applied. We can call it voltage applied, we can call it voltage total, but we know that's 120 volts because we just calculated by doing the sum of those. We could have also, another way we could have done that, we could have found the voltage across R1, V1, we'll call that I times R. And same 4 amps times the 10 ohms. That would have gave us 40 volts. We could do V2 for the voltage across the 20 ohm resistor. I times R again. Same current, series circuit. Current same everywhere. 4 amps times 20 ohms gave us 80 volts, and VT would equal V1 plus V2, which would equal V1 40 volts plus 80 volts equals 120 volts. So we found two different ways to calculate that. And let's put our voltage here, V1 equals 40 volts, we just calculated. V2 equals 80 volts, which we just calculated. And so we can see quite clearly that 80 plus 40 gives us 120 volts here, which is the applied voltage or the total voltage, whatever you want to call it. That's why I use both here. And we're going to find that same voltage applied across R3 and R4. Now, let's figure out what the current in branch 2 is. We have the total current, 6 amps. We have I1. We do not know yet I2, but let's put an arrow here. We're going to figure that out. Well, we know that I total will be the sum of the branch currents, which we have 2, I1 plus I2. There's our current summation formula that we've seen quite a few times now. I total is given to us, so we have 6 amps. I1 was given to us, which we have 4 amps. But I2 we don't know. That's what we're going to find now, plus I2. Well, we're going to subtract 4 amps from both sides of this equation. Remember, we do the same thing to both sides of the equation. We keep the equation balanced. We maintain our equality. Well, 6 amps minus 4 amps leaves 2 amps, and 4 amps minus 4 amps is 0 amps. All that's left is I2. So we know that I2 is equal to 2 amps. We'll write that right here, 2 amps. And we see 6 amps splits up into 4 amps and 2 amps. And 4 plus 2 recombine again to make 6 amps here. And all the arrows are negative, positive, indicating we're working with electron flow. Now we know from our calculation of V applied that also appears 120 volts from here to here. It's kind of hard to, well, I'm going to draw it. 120 volts from there to there. Across the combination, the series combination of R3 and R4. Well, we'd like to find what voltage 4 is. How would we do that? Remember our voltage total formula? Voltage total equals voltage 1 plus voltage 2 plus voltage 3, however many we got. And this is for a series circuit. The voltage total, or voltage applied, either whichever you like to call it, is the sum of all the voltage drops in the circuit. We only have 2 to deal with here, so we're going to just leave it like that. Well, we know voltage total. We just calculated that. We know it's 120 volts. And we know the sum of V1 plus V2, which would be, no, that's volts, excuse me, we got to get the subscripts from that. This is going to be V3 and V4. V4, V3, and V4. We know the sum of those voltages is going to equal 120 volts. Well, we have this voltage equals I times R. We can use that formula to determine what V3 is. So we're going to say that V3 equals I2, the current through that branch, which we calculated by using our current total formula basically. V3 equals I2, and we're going to multiply that times R3. R3 is 10 ohms. And, well, let's not put the value in there yet. Times R3. V equals I times R. So V3 equals I3, which is 2 amps, times R3, which is 10 ohms, basically equals 20 volts. So we got V3 equals 20 volts. Let's write that right here. V3 equals 20 volts. Now, we have our voltage total formula. Now we have everything but one thing. We have the VT, We didn't have V3, we just calculated V3, so we'll take the VT, V total down, and we'll replace V3 with what we just calculated to be 20 volts. And V4 we still don't know, that's what we're working on figuring out here. We got our equation, we can subtract 20 volts from both sides. 120 minus 20 leaves 100 volts. 20 minus 20 is 0, so we have the V4 equals 100 volts. So let's put that here. V4 equals 120 volts. So what do we got now? We've got the total current, we've got the current to this leg, current to this leg, we've got the resistance here, we've calculated the voltage here, we got the resistance here, we've calculated the voltage here, we got the resistance of 3, we've calculated the voltage across. The only thing we have left to find here is what is R4. Well, let's see, what choices could we have to find R4? We got voltage equals current times resistance. Well, we don't have the resistance yet, so we can't use that formula, can we? We have voltage equals, well, we're trying to find resistance, but yeah. What choices do we have for formulas to find resistance? We have two of them. Resistance equals voltage divided by current, and we have resistance equals another choice here? Oh, okay, yeah, we can solve this guy for resistance, so that becomes, that's what we just did. Seems like I have two choices here, but no, it doesn't look like I do. Okay, so we don't know the resistance. We do know the voltage, and we do know the current. So that's going to be the method we use to solve for resistance. So taking this formula here, R equals V over I. So I'm going to say that R4 will be equal to V4, which we've calculated, over I2, which we calculated. So V4 was, that's 100 volts. Why did I write 120 there? We just, 120 was supplied, we subtracted, 100 volts. So we get 100, let's write that a little more clear. And let's write it the same color that we used, equals 100 volts. So we can substitute our 100 volts that we calculated a little earlier. We'll divide that by I2, which is 2 amps. Well, 100 volts divided by 2 amps because it's 50 ohms. So now we've fully solved that circuit. I'm going to erase this question mark, put 50 ohms here. So now we know all the resistors. 3 of them were given to us, we solved that one. We know all the currents, 2 of them were given to us, we solved that one. We know all the voltages, and we were able to get these two ways. We were able to current times the given current times the given resistance, given current times the given resistance. We were able to get the voltage across R1 and R2, which summed up to 80. The other thing we were able to do was the total resistance of 30 ohms times the 4 amps gives the total voltage. So we got all the voltages, we have all the resistances, we have all the currents. So we've basically fully solved that particular problem now. And another thing I want to point out about this problem, this was another one because there was no series resistance. We were able to find the total voltage without ever calculating the equivalent resistance of this circuit. We were doing piece by piece, use our voltage drop formulas, Now, once we're all done, we could do the one. Well, we could have done that in the beginning. No, we didn't know that. But we could say that RT would equal to VT, the applied voltage, divided by the total current, 6 amps, which would be 120 volts divided by 6 amps. That's going to be 20 ohms, right? 120 volts. Yeah. And we could use our sum these up, do our 2-branch parallel resistance, and solve that, and should get the same thing. One thing we do know is that each branch, this is going to be less than any of the branches. Well, this branch is 30, this branch is 60. 20 is less than 30, 20 is less than 60. So we've solved that one. It went out, came across nicely, I think. And we illustrated that we did not, the point we talked about earlier, we did not need RT to solve for VT. Now we could have we couldn't have went that route because we didn't have R4 to start with. We're going to erase this. We're going to move on to another example. We got quite a few examples to do, and doing the examples is, I believe, helpful for your understanding. So, we're going to draw another circuit up here. We got a couple of parallel resistors. And we have R1 equal to 20 ohms. We got a voltage called VT, applied voltage here. We have another resistor here. We're going to put polarities negative and positive on here. We're given an IT equal to 3 amps. We're given here, we'll call this I1, the current through R1, which we're given that as 2 amps. We don't know R2 yet. Put a question mark there. We're given R3, which is 20 ohms. So let's think about what we would like to find all the voltages and all the currents in this circuit. So what do we know? We know that this IT travels in the main line here. It's going to split in some fashion through these two parallel branches. It's going to rejoin, and it's going to go right through R3 and around back to the source. So we can see right away that because it recombines, we'll call this IR3, we may use this, is equal to that same 3 amps. It's the same thing as IT. The current through R3 is the same thing as the total current. Let's start by finding the voltage across. If we find this voltage and then we find this voltage, we can sum them up, get the total voltage. So let's find the voltage across R3. Remember, voltage equals IR, because we have I, 3 amps, we have R of 20 ohms. So let's say that V3, the voltage across V3, is going to be equal to IR3 times R3. Now let's substitute in our known values. We have 3 amps times R3, 20 ohms. Which gives us 60 volts. 3 times 20, 60 volts. So we're going to call this V3 is equal to 60 volts. Well, that's nice. We got one of the voltages down. Now let's calculate V1, the voltage across resistor 1. We're going to use the same formula, V equals IR. We're going to call it V1 equals IR1, the current through R1, times R1. Well, we were given the current through R1, which we could call I1 as well, but I guess for consistency I'll call it I1, being that's what we called it up here. That was 2 amps. And we were given the value of R1, which was 20 ohms. Well, 2 amps times 20 ohms is 40 volts. Now let's write that up here. Let's go V1. So we calculated this voltage, we calculated this voltage. How will we find this total voltage? Well, remember the formula. VT equals V1 plus V2 plus V3 and on out. And that is the way the voltages sum up in a series circuit. We have a series circuit. This parallel network is in series with this resistor, or we can call this resistor bank is in series with this resistor. We know the voltage across that entire parallel network or resistor bank, because parallel circuits, voltage here, same as voltage here, voltage here. So we know this voltage, we know this voltage. They're going to sum up to be the total voltage. Now we've only got 2, let's erase our extra ones here. And let's use that formula. VT equals V1 plus V2. Well, V1 we just calculated to be 40 volts. V2 we calculated a little bit ago to 60 volts. And 40 plus 60 is 100 volts. So we're going to put that 100 volts right here for VT. Put a little equal sign there too. 100 volts. So what is left that we don't know about this circuit? Well, we don't know I2, which would be the current through R2. We don't know the value of R2. We do know the voltage, going to be the same as the voltage across R1. Well, let's think about how would we find the pieces we need. We want to find R. We have a formula that R equals V over I. Well, we got the voltage. We don't have I, but we have a way of finding I, because we know that IT, and this is how current divides up through parallel branches, is going to be the current in branch 1 plus the current in branch 2 plus the current in branch 3 for however many parallel branches we might have. Well, we have only 2 here, so I'll erase the extra just to keep from getting confused here. IT given to us, 3 amps. I1 was also given to us, which was 2 amps. 2 amps plus I2. Well, as always, same thing to both sides of the equation. Subtract 2 amps, subtract 2 amps. 3 amps minus 2 amp. What the heck? Okay. Yeah, that's what I want. We have 1 amp, and 1 amp equals I2. So let's put this on here. I2 equals, let's use the same color we labeled it with. So now we have the voltage and the current, which is what we need to find the resistance. So we're going to say that R2 will equal V1, which is the voltage across R2 in this case, because the voltage across R2 and R1 are the same, V1, divided by the current I2 through R2, which, so now we're going to substitute in our values. Our voltage 1, which is the same as the voltage across R2, by the way, is 40 volts. And our current is 1 amp. Well, 40 divided by 1 is 40 ohms. So we have R2 equal to 40 ohms. Now we could have let's put a V2 down here too, equal to the same voltage, because they're parallel. We could have taken note of the fact that we could have said, and let's go ahead and do that, R2 equals V2 divided by I2. And we could have realized from this here that V1 equals V2 equals 40 volts. They're all equal 40 volts. And then we could have done our substitution a little differently. After recognizing they're equal, it'd be the same, but we would look here and say that V2 is 40 volts and put the 40 volts here. And I2, which we calculated earlier from the current summation formula, was 1 amp. And 40 divided by 1 was 40 ohms. So basically, what have we seen here? We've everything looks exactly the same, but because V2 and V1 were the same, as we see here, and as we see by our understanding parallel circuits by looking at the schematic here, it really didn't make any difference which we chose, because V1 and V2 are the same results, same numbers. But what we were showing here, we had no, we didn't. Okay, I think that covers that one. We've analyzed that pretty good. We found our applied voltage by calculating this voltage and this voltage, summing them up. We found our resistance here by doing the current divider formula, and the resistance equals voltage divided by current. We used that formula to come up with what R2 was. Where did we do that? I know we did it. Well, I'm going to write it up here one more time just to... Oh, there it is. Voltage divided by current. There it is. That's what we've just been talking about so much. And some of the voltages, we looked at the division of the current, 3 amps, 2 here, 1 there, recombined. Let's put that arrow in here. There's 3 amps here. Oh, we already did that at the very beginning. So we've done a combination there. Let's analyze another series parallel circuit. I got one more. It's a little more complicated, and this will probably finish us off for the day. We're going to draw this circuit up on the board. And we've got, this guy is going to have, how many resistors in it? This is going to have 6 resistors in it. Let's make that a little neater so it's a little easier to see. We've got 80 volts applied to this thing. We're given that. And again, we're going to do the negative, positive. All our currents are going to flow in this direction. This is electron flow, which goes from negative to positive. Oh, we're going to start by putting our resistance values here. R6 equals, we're given 8 ohms. R5 equals 16 ohms. R3 equals 20 ohms. R1, 10 ohms. R2, another 10 ohm resistor. R4, 6 ohms. Let's see. We're going to want to find a bunch of things here. I think I've got everything we provided. That's all we provided is resistance values. We want to find IT. We want to find I5, the current through resistor 5. We want to find I4, the current through resistor 4. We want to find I3, the current through resistor 3. We want to find I1 and 2, which is going to be the current through R1 and R2. They're in series. It's going to be the same current. And we're going to want to find all the voltages too. We're going to want to find V5, V3. We're going to want to find V1, V2, V4, V6. So our goal here is to find all the resistances and all the currents and so on. Now this guy, we have this series resistance in the main branch, in the main line. We're going to solve this one by working back and finding the total resistance, which will give us IT, and then we'll use our current divider formulas and voltage. Then we'll calculate current here, and the current divider formula gives current here. We'll keep working our way back till we get to the top, have all of these things solved. Well, we're going to take several steps we're going to take to simplify this circuit. It's kind of complicated one. Our goal is going to get to a single circuit that's going to look like this. 80 volts across a single resistor. That's going to be our goal. And when we get to that, we'll work our way forward. Now, how are we going to do that? Well, let's start by taking R2 and R1. R2, that will combine into a single resistor of 20 ohms. So if we replace that with 20 ohms, we're just going to look at this piece right now. We would end up with R3, the 20 ohm resistor. If we replace R2 and R1 with a single 20 ohm resistor, so we have 20 ohms here, 20 ohms here. Looks like that. Two parallel resistors of equal value is going to become, remember the formula? It was R equivalent, or let's call it R total. R total equals R over N. If they're both the same value, we can take the value divided by the number of them, and that gives our total. Well, we have here 20 ohms divided by 2, which is going to be 10 ohms. So once that says, we can replace that whole thing with a single 10 ohm resistor. So we're going to redraw this circuit that way. I'm going to draw this particular one with a different color to indicate that is what we replaced this whole thing with. We still have R6 equal to 8 ohms. We still have R5 equal to 16 ohms. We still have R4 equal to 6 ohms. And this thing here, you see that this piece here is the same as this here. But this particular piece has been replaced with a single resistor, which we found to be 10 ohms in value. Now, because it's going to get a little cluttered, I'm going to erase this piece now to give us more room to do the next. And we're basically going to do the same thing here. R4 of 6 ohms in this equivalent resistor here, 10 and 6. So that becomes replaced with a single 16 ohm resistor. We're going to look at this piece. We still have this other 16 ohm resistor. So we have two 16 ohm resistors. This one and that one. Well, we can replace that with a single resistor. And we know that RT is equal to R over N because these are equivalent, 16 ohms, 16 ohms. 16 divided by 2 is 8 ohms. I'm going to leave my 80 volts on here. I didn't want to get rid of that. So we've found a way to replace this whole piece with one resistor of 8 ohms. So we're going to put our 80 volts here. Minus plus. R6 doesn't change. That's still 8 ohms. But we're replacing all of this with a single 8 ohm resistor. So we're going to do that. And I'll do that again with a different color to indicate that's where we replace stuff. And that was a single 8 ohm resistor. So we've simplified the circuit a little more by adding these two to get 16, recognizing that it was in parallel with 16, which gave us an 8 ohm, which allows us to replace that whole thing with this 8 ohm resistor. Again, let's replace this because the board's going to get cluttered here. But we're getting pretty close, aren't we? We started out with this. All we have left is these two resistors. And that's fairly easy. We have two resistors in series. They're both 8 ohms. 8 plus 8 is 60 ohms. So we're going to draw, I'm going to go right over here and draw that. 80 volts. So we replace this with a single 16 ohm resistor. Yeah, I think I want this down here because I'm going to need more board. 80 volts. So we're going to work our way back now. We've got this thing down to a single resistor. We can now do IT. It's going to be this voltage divided by that current. So we're going to do the IT first, and then we'll put it on the drawing. Well, IT equals voltage applied or voltage total, which was 80 volts, right? VA divided by 16 ohms, or divided by RT, which we calculate here. So that becomes 80 volts divided by 16 ohms, which works out to 80 volts. 80 divided by 16 gives me 5 amps. So let's put that on the circuit there. IT, we just calculated. 5 amps. So at least one step closer to solving this problem. Now let's calculate R6 or V6. We now know that there are 5 amps. Let's write that here too. Well, we'll leave it. We now know that there are 5 amps through R6. We know the value of R6. So we calculate V6. V equals IR. So we're going to say that V6 is equal to 5 amps times resistance of R6, which is 8 ohms. And 5 times 8, 40 volts. So let's write that V6 equals 40 volts here. What's the next thing we want to calculate? Well, let's determine V5, the voltage 5. So we have our, now this is applied voltage, a voltage here, and a voltage here. So this is our series voltage. The voltage here plus the voltage here, so there's voltage 5 plus voltage 6 will equal our applied voltage, which we could call that VT. We didn't label it that way, but we'll put the formula up here. VT equals V1 plus V2 plus whatever we have. In this case we have V6, V5, so we're going to change the labels that way, get rid of them. V6 and V5. We're trying to find V5. We know VT, it was originally given to us. 80 volts equal to V6, which we calculated a few minutes ago, of 40 volts. Plus V5, which we don't know, and that's our object right now to find V5. Well, subtract 40 from both sides, we end up with 80 volts is equal to V5. Or 40 volts, excuse me. 80 minus 40 is 40 now. 40 volts for V5. Let's put that on our drawing here. So I'm going to erase that because we really don't have a board to go forever. Let's find out the current through 5. Well, we have a current formula, which I is equal to V over R, and we just calculated the voltage. We were given the resistance. So let's call that I5. I5 will be equal to R5 divided by V5, which we were given R5, that's 16 ohms. V5 we just calculated, which was 40 volts. I got that upside down. It's voltage divided by resistance. I5 is voltage 5 divided by resistance of 5. And we just calculated the voltage, 40 volts. And we were given the resistance, 16 ohms. And if we divide that out, that gives us 2.5 amps. 2.5 amps. So let's put that down here for I5. 2.5 amps, and put equal sign. 2.5 amps is equal to I5. So we have calculated I5. We're working our way through the circuit like gangbusters, aren't we? I4. Well, remember our current summation formula between parallel branches. We have I total equals I1 plus I2 plus so on. In this case, we have I total, I5, and I4. So we're going to use the I total we have. We've just calculated I5. We're trying to find I4. So that will say that 5 amps is going to be equal to this 2.5 amps plus whatever that is. So let's write it out there. Substituting the values right here. I total 5 amps, which we got from right there, is equal to I5, which is 2.5 amps, 5 amps, plus I4. Now we're going to subtract the 2.5 amps from both sides. 5 minus 2.5, 2.5 amps is equal to I4. We used our current division rules here, our current summation rules. So I4 was now 2.5 amps. We're getting closer and closer here. Well, if we can have the voltage here, we can take 80 minus 40 minus whatever that is, it'll give us the voltage here. So let's look at our voltage formula again, which we have right there. And our voltage summation formula for a series circuit, we'd like to find the voltage of this plus this plus this. But let's first calculate the voltage for, because we're going to need voltage for to do that. So V4 is going to be I4, and I'm going to multiply that times R4. And we just utilize that voltage equals IR formula. I4 we calculated to be 2.5 amps. And we're going to multiply that times R4, which was 6 ohms. And 2.5 times 6 is going to be 15 volts. So we have V4 equal to 15 volts. Now to find V3, we'll use our total voltage summation formula. Remember, that's voltage total equals V1 plus V2 plus V3 plus whatever we have. And that is how the total voltage adds up in a series circuit. Well, we got this voltage across V3 plus this voltage across V4 plus this voltage across V6 to get our total voltage. So we're gonna put those subscripts in, the ones we're actually going to use for this particular problem. We have V6, we've calculated that. We have V4, we've calculated that. We're looking for V3, which we do not know yet. So that's what it's going to look like. So V total, we're given that, 80 volts, equal to V6, 40 volts, plus V4, 15 volts, plus V3, which we don't know. Now I'm going to simplify this circuit maybe a little bit different way than... First I'm just going to add these two together. 80 volts equals 40 plus 15. Erase that, it's a little more clearer. We do it. 80 volts, our voltage total, will equal 40 plus 15 is 55 volts, plus V3. What we've done here is just combined V6 and V4 into a single number. Subtract 55 from both sides. 80 minus 55 will be 25 volts equals V3. So we have now solved the voltage for V3, which was, we'll put it right on the diagram here, with 25 volts. So we have current coming in here, 2.5 amps. We don't know current here, we don't know current here. We know all these resistances. We'd like to know the way the current divides up so we can calculate voltages and what's left of the circuit. So what do we got? We got our current summation formula, IT equals I1 plus I2 plus, we've only got two of them. IT here is going to be I4. We don't have I3, nor do we have I1. Let's call it just I12. The current that go, yeah, that's how I've labeled it, I12. But we have our current formula, current equals voltage times resistance. We have calculated the voltage here, we have the resistance. So let's calculate I3. I3 will be equal to voltage 3 divided by resistance 3. And we have those. Voltage 3 is 25 volts. And resistance 3 is 20 ohms. So when we divide 25 by 20, we end up with 1.25 amps. So let's put that I3 on the drawing here. Running out of room, so right there, 1.25 amps. So we've got voltage here, we got voltage here, we got voltage here, we've got voltage here. We don't know voltage here or here or current through here. So we're getting pretty close to being done with this problem, aren't we? So let's use our current divider formula with some different subscripts now. Well, it's basically the same one, but we know more values. I4 equals I3 plus I12. We know I4 this is the current, how they split between this branch and this branch. We know I2, 2.5 amps. We know I3, we just calculated it, 1.25 amps. And we're looking for I12. Well, if we subtract 1.25 from both sides, 2.5 minus 1.25 gives 1.25 amps, equal to I12. So let's put that on the drawing right here, 1.25 amps. Now we're getting pretty close. We can calculate the voltage. Well, we know the voltage really, but we'll calculate it anyway. Across, we know this is 25 volts. We know those are equal. We know they're going to divide equally. But let's do it with the IR formula. We know that so we're looking for V2, which is voltage across resistor 2. We know that's going to be equal to IR I12 times resistance 2 so now we can do some substitution. V2 equals I12. We calculated that right here, 1.25 amps. We multiply that times R2, which is 10 ohms. Well, 10 times 1.25 comes to 12.5 volts. Now we could do let's write that here, V2 12.5. We could do the same thing with V1, but current's the same through a series circuit everywhere, so current through R2 and I2 is the same. The values of R2 and I2 are the same, so we're going to get the same result. There's really no point in, well, if I just put R1 here, now we've done it. We substituted to 10 ohms, so basically that's going to be 12.5 volts also. So what did we do here? Let's kind of summarize what we did a little bit, and we'll call it a day. We combined we needed, because of this series resistor, we needed to get the total resistance before we could find anything to work our way back. So we combined R1 and R2. They were 10, 10, 20. We put the two 20s in parallel, replaced it with a 10. We combined the 10 and 6 to get 16. We put the two 16s in parallel, replace it with an 8. We added the 8s together, replace it with 16. This allowed us to get BT. And I'm going to emphasize that right here. I'm going to say IT. IT equals VT over RT, which we found here. VT we were given originally 80 volts, and RT we calculated 16 ohms, and that allowed us to come up with the 5 amps, and then allowed us to work our way back through the whole problem piece by piece. So we worked it down to here. We solved, and basically we did it up here. We basically kept working our way back the other way. We looked at this part of the circuit and so on, and lo and behold, now we know, is there any resistor we don't know the current through? 5 amps here, 2.5 amps here, 1.25 here, 1.25 here, 1.25 here, 2.5 here. So we know the current through every resistor. How about the voltage? 40 volts, 15 volts, 12.5 volts, 12.5 volts, 25 volts, 40 volts. We've completely solved this circuit, and it took us a little while, but see how by logically breaking it down, we broke it down to this equivalent resistance and worked our way back to the top. Anyway, I think that's probably enough for the day. I appreciate you coming back. Be sure to like and subscribe. And until the next time, keep on learning.